Ever pondered why we will never see the Milky Way again, even if we're part of it? Quite a conundrum, isn't it? It's like being a character in a book who doesn't know they're in a story. Or perhaps it's akin to being a fish in the ocean, not quite grasping the vastness of the waters around them. Sure, they might see a few other fish, a patch of coral, perhaps even a sunken treasure chest if they're lucky. But the entire ocean? Not a chance. In the same vein, we Earthlings find ourselves in a similar situation. We're part of the grand cosmic ballet that is the Milky Way, twirling and spinning in this massive galaxy. Yet, despite our place amidst these cosmic twirls and spins, we're unable to see the full majesty of the Milky Way. It's not that we see nothing, mind you. On a clear night, away from city lights, we can glimpse a part of our galaxy, a cloudy band of stars stretching across the sky. But that's just it, a part, a fraction. A tiny slice of the cosmic pizza that is the Milky Way. So why can't we see it all? Well, it's a bit like being at a party, but only seeing the people in the room with you, not the entire guest list. You're part of the event, yet you're not privy to the whole shebang. Quite an intriguing puzzle, wouldn't you say? So why can't we get a good look at our own galactic party? Well, it's a bit like trying to read a book in a pitch-black room. And to make things even more challenging, imagine doing it while wearing sunglasses. That's right, we're talking about the two main culprits behind our limited view of the Milky Way: distance and light pollution. Now, distance is a bit of a no-brainer. We're situated about 26,000 light-years away from the center of the Milky Way. That's roughly 153 trillion miles, or to put it in more relatable terms, that's like driving around the Earth over 6 billion times. So, it's not exactly a Sunday drive, but distance isn't the only thing obscuring our view. Enter light pollution. You see, the Milky Way isn't exactly a bright beacon in the sky. Its light is subtle and easily drowned out by the artificial lights we humans are so fond of. Street lights, buildings, cars all contribute to a sky glow that outshines the subtle glow of our galaxy. It's like trying to spot a candle in a room full of disco lights. And if that wasn't enough, our atmosphere also comes into play. Different atmospheric conditions can scatter light and create a haze that further dims our view. And it's like trying to gaze at a masterpiece painting through a foggy window. So you see, it's not as simple as just looking up and there it is, our grand Milky Way in all its glory. It's a cosmic hide-and-seek, with our galaxy playing the elusive character, hidden behind layers of distance, light pollution, and atmospheric interference. But don't let this discourage you. Remember, the thrill of the chase is often just as exciting as the final discovery, and who knows, maybe one day we'll figure out a way to get a clearer view and finally read that book in the dark without the sunglasses. So, it's not about the Milky Way playing hard to get, it's just that we're stuck in a cosmic dark room. You might be thinking, can't we just send a spacecraft to take a picture? If only it were that simple. You see, even with our most advanced technology, reaching a point in space where we could capture a complete image of the Milky Way is no walk in the park. Let's put this into perspective. Imagine a snail racing a cheetah. The cheetah, in this case, represents the vastness of space, and our snail, bless its heart, mirrors the speed of our fastest spacecraft. Now, the snail is quite determined, and it has some pretty impressive tech strapped to its shell, but the cheetah, it's just too fast, too vast, and our little snail doesn't stand a chance. In reality, our fastest spacecraft, Voyager 1, travels at a speed of about 17 kilometers per second. Sounds impressive, right? However, the Milky Way, our galactic home, spans an estimated 100,000 light-years. So if we were to send Voyager 1 on a mission to capture a family photo of our galaxy, it would take approximately 200 billion years to reach a suitable vantage point. That's longer than the age of the universe itself, which is a mere 13.8 billion years old. And let's not forget, this is a one-way trip. Voyager 1 doesn't have the fuel to make a return journey. And even if it did, the Earth wouldn't be waiting patiently for its return. Our planet, along with the rest of the solar system, is constantly in motion, orbiting the center of the Milky Way. So as you can see, the idea of sending a spacecraft to snap a photo of our galaxy is not quite as simple as it seems. The vastness of space, coupled with the limitations of our current technology and the relentless march of time, makes this task an astronomical challenge. So, unless we've got a few billion years to spare, that's a no-go. But don't lose hope, our tech whizzes are on the case. Technology has always been at the forefront of our understanding of the cosmos, and it's no different when it comes to the Milky Way. From Galileo's Hubble telescope to the Hubble and beyond, we've been peering into the depths of space for centuries, striving to gain a better understanding of our place in the cosmos. Now you may be wondering, how do telescopes and satellites help us understand and visualize the Milky Way? Well, telescopes, both terrestrial and space-based, gather light and other forms of electromagnetic radiation from distant stars and galaxies. They allow us to see the structure of the Milky Way, including its spiral arms and central bulge. They've even enabled us to map out the Milky Way's dark matter halo. That's right, we're mapping out invisible stuff in space. If that's not impressive, I don't know what is. Satellites, on the other hand, have a slightly different role. They help us observe our galaxy from different vantage points, free from the atmospheric distortions that can blur our view. Satellites like the Gaia Space Observatory are mapping the Milky Way in unprecedented detail, providing us with a 3D census of our galaxy's stars and their motions. With such detailed data, we'll be able to better understand the Milky Way's past, present, and future. But here's a funny thing. Despite our technological advancements, despite our ability to map invisible matter in space and track billions of stars, we still can't find those pesky lost socks. It seems that some mysteries, like the location of your favorite pair of socks, are just too great for even our best technology to solve. In the grand scheme of things, our quest to understand the Milky Way is not just about satisfying scientific curiosity. It's about understanding our place in the universe, about answering that age-old question, where do we come from? It's a journey of discovery, one driven by our insatiable thirst for knowledge and facilitated by our technological prowess. So while we might not find those elusive socks, at least we're getting a better picture of our galactic home. So, let's recap our cosmic journey, shall we? We began by exploring the concept of being lost in the Milky Way. A perplexing thought, isn't it? As if we've misplaced our galactic keys and can't quite remember where we left them. The truth is, we're not lost at all, but rather we're situated in a suburb of the Milky Way, a place that's a tad too dusty and gas-filled to offer us a clear view of our galactic home. We then delved into the visibility issues, or what I like to call the Milky Way's shyness. It's almost as if our galaxy is playing an eternal game of hide-and-seek with us. We're just not in the right position to see it in all its glory, much like trying to admire a masterpiece painting while standing with your nose pressed against the canvas. Onwards, we journeyed to the realm of space exploration and our relationship with the Milky Way. We've sent probes, telescopes, and even our dreams into the cosmos, hoping to get a better look at our galactic neighborhood. Yet, despite our best efforts, the Milky Way remains a tantalizing enigma, only revealing parts of its grand design. And then, of course, we considered the role of technology. We've developed sophisticated tools and methods to pierce through the cosmic dust and gas, seeking to unveil the Milky Way's secrets. Yet, ironically, the more we discover, the more we realize how much there is still to learn. It's like peeling an onion, each layer revealing another, each discovery leading to a multitude of new questions. Now, as we reflect upon all this, it's hard not to feel a touch of cosmic humility. We're but stardust trying to comprehend the dustbin we're a part of. It's almost humorous, isn't it? A bit like a single grain of sand on a beach trying to understand the entire shore. But that's the beauty of it, the grand cosmic joke that we're all in on. So, as we conclude, remember this. Just because we can't see the full Milky Way doesn't mean we're not a vital part of this cosmic party. After all, what's a party without a little mystery?